Hey, welcome back. Let's go ahead and solve a super interesting problem. Is a graph bipartite. So what is bipartite? Bipartite is a unique type of graph. So let's see one of the examples. So for example, we have one group and we have another group. And those are the two groups. So for example, the first group is teacher and the second group is students. So we can only have teachers teach students and we can only have students learn from teachers. So my node from the first group can connect with the second group, any member from the second group, and I can have any member from the second group connected with any member from the first group, but I cannot have my first group member connected with the first group. So I cannot have my teacher teach teacher. Hypothetically in this particular property. So I cannot have this guy connected with this guy. I cannot have this guy connected with this guy, but I can have this guy connected with all the second group members. I can have this guy connected with all the first group members. And that's the property with the bipartite. And I actually learned this back in college, so from the graph theory. And there's very interesting algorithms that we can tackle this problem. And let's check one of the example. The solution is pretty self-explanatory. We have two groups. Then we just color both groups with a different color. So maybe the first group, we color them as 0. 0 stands for teacher. And the second group, we color them as a student. And that's color 1. So let's go ahead and check one of the example. For example, the node 0. Let's color this guy as a teacher. So this is 0. The node is 0 and we color this guy as a 0. And this guy is connecting with two other nodes. If this guy is a teacher, the neighbors has to be, if this guy connected with this guy, it has to be a student, which is node 1 will color as 1. Node 3 will also color as 1. So this guy colored as 0, and this guy colored as 1, and this guy also colored as 1. And we come to this guy, and this guy is connected with this guy. If this guy is colored as 1 and this guy has to colored as 0, will this guy colored as 0 satisfy this two relationship? We know this is 1 and this is 0. Okay, perfect. So they actually match. Now we can return true because this is satisfied with bipartite property. And let's check one more example. We have this guy colored as 0, and this guy now is connecting with all three nodes. All three nodes will color as 1, 1, 1. We have 3, 1 right here. Now let's check this pair. If this guy colored as 1 and this guy colored as 1, and they're connected, and that doesn't make sense. That breaks the bipartite property. So when two nodes are connected, they have to be split into two different sets. But this guy already assigned all three other nodes, the neighbor nodes, as from the second set of the group. And this already violates the bipartite law. And now we got it. Okay, so that's how we solve the algorithm. Okay, so now we can go ahead and write the code. And since we know, okay, by the way, so let's go ahead and read the question first. I forgot to do that. Given the undirected graph and return true if and only if it is a bipartite. Recall the graph is bipartite if we can split a set of the nodes into two independent subsets, A and B, and such that every edge in the graph has one node in A and another node in B. And the graph is given in the following form. So graph I is the list of index J, which is the neighbors of the I, and I and J exist. So every node is an integer between 0 and the graph length minus I. So those are all integers, so we can just loop through that. And there are no self-edge or the parallel edges, and graph I does not contain itself. So there's no self loop, and it doesn't contain the duplicates as well. Sounds great. So let's go ahead and start writing the code. And since we know that all the nodes are given is between 0 and the length minus 1, so we're just gonna define n right here. And also we need to check if a node is being calculated or not, and we're gonna do that by using a visited vector. So we're gonna use a vector to define if a node is being computed or not. So we are gonna split the entire thing into 3 different sets. -1 stands for unvisited. So that's our initialization we have. And 0 stands for group 1, and just like we did in the example. And 1 stands for the group 2. Group 2. Okay. So we have 2 groups, either 0 or 1. And for those uncalculated, those are -1. And we can start looping through everything, since we are given that the node will be between 0 and also a -1. So we just looping through all of them. We check every single one of the node. And what do we do with each node? We start checking if we already visited this node before. If we never visit this node, then we're in the condition 1, right? So this is -1. So if it's not equal to -1, then we just continue. Forget about it. We are not going to do anything about it. We already checked this before. And we start doing BFS. So BFS is standard, right? So we need a DQ as our double-ended DQ. And we're going to put initial position. So what's the initial position? That's an interesting question. So definitely we need put a node in, right? So we definitely need to put, instead of putting I, let's put a node. That'll be easier to understand. We put a node into our initial position, and also we put a color. We color the first guy as 0, and we just put 0 right there. That's the color 1. Now we have 1 color, and we store that. So that means like our current node will be equal to 0. So the current node will color as 0. We will put that as into our visited. So just in case we want to call back later. And then we can start doing the BFS, and the BFS will come back to pop from the left, and we're gonna deal with them one by one from the queue. And then we start checking. That's typically most of the graph problem, right? We're checking out the neighbors in graph node. So we already colored this guy as 0, and we wanna color all its neighbors as 1. So that's why we loop through all the neighbors. And then we check if the neighbors are already being calculated. So if the neighbor is already being calculated, and then we do one thing. So this is a better example, right? So we loop through here and we check if this guy is already being calculated. It does, because 0 already colored this guy as 1. So once we loop through here, we check its neighbor as well. 2 is also his neighbor. And we check, hey, wait a minute. So you already being visited, you already have a color, and let me check your color if you are the color I want. If you're not, return false. So that's what we do. And we're gonna check if visited the neighbor. So if my neighbor, the color is not the opposite color with my current color, then you're wrong. So I'm gonna return false. And otherwise, I'm gonna continue doing the visited, right? So I'm gonna store this guy as the opposite color. And I'm gonna start append this into the queue so we can deal with this in the next iteration. So this is also gonna be a 1 minus the color. And so if none of this return false, if we loop through every single one of them, and then we check all the pairs with neighbors, just like this guy, and all of them doesn't have a conflict, perfect, we just return true. Let's check this. Great. Okay, looks correct. Okay, perfect. So now we got it. So let's revisit what we have, right? So the visited is going to be recording the color of each node. And we loop through every single node. And we check if this guy is being calculated before. Okay, forget about it. So we just leave this alone. And we continue to do BFS if we never calculate this node before. So we colored this guy. So initially we colored this guy as 0. And then we put all each neighbors to the opposite color. So for example, if the node is 0, and we're gonna cover this as 1. If the node is 1, we're gonna cover this as 0. So we're gonna just use 1 minus the color. So we color all the neighbors. We're gonna cover all the neighbors to opposite color. But what if the opposite or the neighbors are already being colored? And then if we have conflict, we return false. If we have conflict, we return false. Otherwise, we just put this into the visited, and then we do the next iteration. The next iteration will be putting this back into the queue, and we're gonna calculate this again until we finish the while loop. Okay, sounds great. All right, so I'll see you guys in the next video.